Welcome to your personalized deep dive. Today, we're going to crack open the world of software development and testing. You've given us a really interesting mix of sources, some in Russian and some in English, so we'll do our best to weave it all together.
It's going to be fun.
Yeah, I'm looking forward to it. It'll be like your express lane to understanding how software is born. Going from that initial spark of an idea all the way to a fully functioning application. We'll be your guides exploring the stages of something called the SDLC, which stands for Software Development Lifecycle.
It's like a roadmap for creating software.
Perfect analogy. And because we know you're interested in not just the what's, but the why, we'll be unpacking the crucial role of testing.
That's where things get really interesting.
Okay, so are you ready to level up your tech knowledge?
I am. Let's dive in.
A lot of people think software development is all about coding wizards, like those guys hunched over their keyboards, just typing away. But it's so much more than just writing lines of code. It's about having a structured process.
Okay, so a life cycle. Yeah, a life cycle to make sure we create high-quality software that actually solves problems.
Yeah.
That it meets users' needs.
Okay, so it's less about magic and more about having a well-defined plan.
Exactly.
So tell me more about this SDLC roadmap.
The SDLC, it's all about bringing order to the chaos, right? It's a framework. It helps teams navigate the complexities of software development.
From beginning to end.
Yeah, from the initial planning stages all the way to the ongoing maintenance.
Okay, that makes sense. Our sources define it as a cost-effective process for building high-quality software. But why? Why is this framework so important? What problems does it solve?
I think one of the biggest challenges in software development is managing expectations
Yeah.
and also just like keeping everyone on the same page.
Yeah, for sure.
So the SDLC kind of solves this by providing a clear roadmap that everyone can follow. Developers, testers, project managers, clients, you name it.
So it's a shared understanding.
Exactly.
That makes sense. And that helps, minimize those project risks that we all dread.
Exactly. Keeps things moving smoothly.
So the SDLC is like this universal language that helps everyone speak the same language.
I like that, yeah.
It helps avoid those frustrating miscommunications that can really derail a project.
That's a great way to put it.
Yeah.
And by breaking down the development process into these distinct stages, the SDLC allows, teams to focus on one step at a time. So they can make sure that each phase is completed thoroughly.
Before moving on to the next one.
Exactly.
That makes a lot of sense. So walk me through the key stages that make up the SDLC.
Well, it all starts with planning, of course.
Okay.
That's where the team gathers requirements. They analyze, the feasibility of the project. They estimate costs. They set timelines.
It's like laying the foundation for a house.
Exactly. You need a solid plan before you can start building.
Right? So it's all about gathering those blueprints, making sure everyone agrees on what we're building and how we're going to build it.
You got it.
What happens after the planning phase?
So then comes the design phase. And this is where those requirements that we gathered, we translate them into a concrete plan for building the software.
So the engineers, they're like the architects.
Exactly. They decide on the technology stack, the architecture of the system, the user interface, the whole 9 yards.
Oh, wow. Okay. So we've got the plan, the blueprints, and now we're starting to see the structure of the software take shape. What's next? Is this where the coding wizards come in?
You bet. The implementation phase, that's where those lines of code start coming to life. Developers take that design document and turn it into, a working piece of software.
Okay, this is where the magic happens.
This is it. It's like the construction crew putting those bricks and mortar together.
It's starting to feel like a real application now, but I bet there are a few crucial steps before we can call it finished.
You're absolutely right. Before we release any software out into the world, we have to make sure it's rock solid.
Okay, yeah.
That's where testing comes in. It's like the building inspector coming in to make sure everything's up to code.
Making sure it's safe for people to use.
Exactly.
Testing sounds like a pretty big deal. What are we actually looking for when we test software?
Testing is all about finding and fixing those pesky bugs. They can creep into even the most meticulously crafted code.
Oh, yeah. They always seem to find a way.
They do. They do.
So we check for functionality.
Functionality, usability, performance, security, you name it.
So basically, we want to make sure that the software actually does what it's supposed to do.
Exactly. That it's easy to use, that it can handle the load, and that it's secure from those nasty cyber threats out there.
So we're making sure it's not just a pretty facade,
Yeah.
but, a solid structure built to last.
Absolutely.
Okay, so what happens once the software passes all of those rigorous tests?
Then it's time for deployment. This is where we release the software to the users. It's like the grand opening of that house, where people can finally move in and start enjoying it.
That's the exciting part, seeing your creation out in the world. But the journey doesn't end there, does it?
Not at all. Just like a house needs ongoing maintenance.
Yeah.
Software requires that constant care and attention.
So that's the maintenance phase.
That's right, the maintenance phase of the SDLC. We fix bugs that pop up, we address user feedback, we make updates to keep the software running smoothly.
It's an ongoing process of refinement and improvement.
Yes.
Making sure the software stays relevant and valuable to users over time.
Exactly. The SDLC is a continuous cycle, right?
Yeah.
It's ensuring that software evolves and adapts to meet the changing needs of its users.
Okay, so we've got this solid framework, the SDLC, guiding the entire software development process. But I'm curious, are there different ways to approach this journey? Our sources mention a variety of SDLC models.
You're right. There's no one-size-fits-all approach to software development.
Okay.
Different projects have different needs, and that's where these various models come in. Let's start with the waterfall model, a classic approach. It's been around for decades.
The waterfall model, it sounds pretty rigid, like a cascading series of steps.
You hit the nail on the head. The waterfall model is all about sequential progress. Each stage flows into the next, just like a waterfall.
Yeah.
It's a very structured approach, very linear.
Which can be a good thing.
It can be a good thing in certain situations.
So when would the waterfall model be the right choice for a project?
The waterfall model, it really shines in situations where the requirements are very clear and they're unlikely to change.
Okay, so you know exactly what you need to build.
Exactly. And documentation is paramount. Think of large-scale government projects or maybe a mission-critical system where every detail needs to be meticulously planned and documented.
So precision and predictability are key.
Exactly.
But I imagine there are some downsides to being so rigid, especially in today's fast-paced world.
You're absolutely right. The waterfall model's biggest weakness is its inflexibility.
Okay, yeah.
If the requirements change mid-project, which happens quite often in the real world, it can be difficult and costly to adjust the plan.
So if you need to be able to pivot and adapt quickly, the waterfall model might not be the best fit.
Exactly. That's where models like the spiral model come in.
The spiral model. Okay, I'm intrigued. I like the name. It evokes a sense of movement and evolution. What makes it spiral-shaped?
The spiral model is all about managing risk. It embraces change. It's visualized as a spiral because the project cycles through 4 key phases. So you've got your planning, your risk analysis, engineering, and evaluation. And this happens multiple times. Each cycle builds upon the previous one.
So it's constantly assessing the landscape and adjusting course as you go.
That's a great way to put it.
So instead of rigidly sticking to a plan, the spiral model allows for course correction and refinement along the way. When would this approach be most beneficial?
The spiral model is a good choice for large, complex projects where the requirements are uncertain or likely to evolve, and where risk mitigation is a top priority. Think of groundbreaking technology projects or maybe research and development initiatives, where you're venturing into uncharted territory.
Okay, so it's about embracing the unknown and being prepared to adapt as you learn more.
Exactly. Now let's move on to a model that's become incredibly popular in recent years, the Agile model.
Agile. It's a buzzword that's everywhere in the tech world these days. What's the key philosophy behind it?
Agile is all about flexibility, collaboration, and delivering value quickly. It breaks down those large SDLC stages that we talked about into smaller iterative cycles.
Okay.
And we call these sprints. Typically, they last 2 to 4 weeks. It's like running a series of short races instead of one long marathon.
So instead of trying to plan everything up front, Agile teams focus on delivering working software in short bursts.
Yeah.
Gather feedback, adapt as they go.
That's the essence of Agile.
I see why it's so popular in today's fast-paced world. So what are some of the advantages of going Agile?
I think one of the biggest benefits of Agile is that it fosters collaboration and communication. Teams work closely together, they share progress, they address roadblocks, they celebrate wins. It's a very people-centric approach,
Okay.
and that can lead to higher team morale and productivity.
So it sounds like Agile is not just about building software, it's about building strong teams and fostering that culture of continuous improvement.
Absolutely. And by delivering working software frequently, Agile teams get that early and continuous feedback from users.
Yeah,
which helps them stay on track, right?
right.
To
Yeah.
deliver a product that truly meets their needs.
This overview of SDLC models has been really helpful. So it sounds like each model has its strengths and weaknesses.
It does.
And the key is to choose the approach that best aligns with, the specific project needs and the team dynamics.
Exactly. There's no one-size-fits-all solution in software development.
Okay.
It's about choosing the right tools and methodologies for the job.
Speaking of tools, we can't talk about software development without diving into the world of software testing.
Absolutely not.
It's like the quality control process,
Yeah.
It makes sure that the software is ready for prime time.
It's an integral part of the SDLC,
Ooh.
regardless of which model you choose. It's about making sure the software is not just functional, but also reliable, secure, and user-friendly.
It sounds like there's a whole universe of testing concepts and techniques to explore.
There is.
Where do we even begin?
Well, first let's make a distinction between two key concepts: quality assurance and quality control.
Oh, a QA and QC. I've heard these terms thrown around a lot. What's the difference? Are they just fancy names for the same thing?
They're definitely related,
Okay.
but they have distinct focuses. Quality assurance, or QA, it's like the preventative medicine of software development.
Oh, okay.
It's about building quality into the process itself, setting standards, defining best practices, and preventing defects from occurring in the first place.
So QA is about establishing a culture of quality,
That's a great way to put it.
like building a solid foundation for a house so those cracks don't appear later on.
Exactly. QA is all about those proactive measures that make sure quality is baked into every single stage of the development process. It's about creating a really robust framework that minimizes the risk of defects.
So QA is about prevention and QC is about detection and correction.
Yeah, that's it.
Okay.
Now, within the realm of software testing, there's a structured process called the Software Testing Life Cycle, or STLC.
Okay, the STLC, another life cycle. It seems like everything in software development follows a structured process.
It does.
So what are the key stages of the STLC?
It all starts with understanding what needs to be tested, right?
Okay.
So in the requirement analysis phase, testers carefully examine that software requirements document
Yeah.
to identify the key functionalities, the features, the user scenarios that need to be validated.
So it's about translating those requirements into testable scenarios.
Precisely, making sure every aspect of the software is covered. Once we know what needs to be tested, we create a test plan. This is a strategic document. It outlines the testing objectives, the methodologies, timelines, the resources needed. It's like creating a battle plan for the testing army.
A battle plan. I like that analogy. So the test plan provides a clear structure and direction for the testing effort and ensures that everyone's on the same page.
Exactly. With the plan in place, we move on to test case development. This is where testers create those detailed instructions for each test.
So these test cases are like the individual missions
Yeah.
that the testing army will execute, right? Each one designed to target a specific aspect of the software.
That's a great way to put it. Test cases are detailed scripts. They outline the steps to be executed, the inputs to be used, and the expected outcomes.
They make sure that the testing is consistent, repeatable, and thorough.
Exactly.
Yeah.
But before we dive into the different levels and types of testing, let's talk about some fundamental principles that guide the entire testing process.
Okay, principles, you mean like the guiding rules.
The guiding rules for effective testing.
This is where it gets really interesting. Give me those testing principles. All right, testing principles. These sound like the commandments of good software development. What are they?
Well, one of the most important principles is that exhaustive testing is, well, it's simply impossible.
Wait, so you're saying you can't test absolutely everything, but isn't that the point of testing? To make sure everything works perfectly.
That's the ideal, of course,
Yeah,
but
why?
in reality, software is incredibly complex. It can have an almost infinite number of possible inputs, interactions, and scenarios. Testing every single combination, it would take forever.
Yeah, we'd never actually release any software.
Exactly.
So how do testers deal with this? How do they choose what to test?
That's where strategy and prioritization come in. Testers use a variety of techniques to focus on, like, the most critical test cases, the most representative ones.
The most important ones.
Yeah, exactly. They analyze the requirements, they identify high-risk areas, and they prioritize those tests that cover the most common user scenarios. And of course, those potential points of failure.
So it's about working smarter, not harder.
Exactly.
Making the most of limited time and resources to get the best possible coverage.
You got it. Another key principle is that testing, it doesn't eliminate all defects. It just reduces their probability.
Okay.
Think of it like this. Even the most thorough medical checkup, it doesn't guarantee you'll never get sick,
Yeah.
right? It just increases your chances of staying healthy.
So even if all the tests pass, there's still a chance some bugs might be lurking in the shadows, just waiting to strike at the worst possible moment.
Yeah, unfortunately, that's true. Software development, it's a human endeavor, and humans, well, we make mistakes. That's why ongoing monitoring and maintenance are so important. Even after the software is released, it's about catching those issues that might have slipped through the cracks.
And addressing them quickly.
Exactly. Now, let's talk about another really crucial principle, early testing.
Okay.
The sooner we start testing, the better.
It's probably easier to catch and fix those bugs while the software is still in development, right?
You got it. Imagine trying to, fix a crack in a house after it's already been built.
Oh, yeah.
Much easier and less costly to address those issues during the construction phase.
Right. So early testing is about building quality into the software from the ground up.
Exactly. And by involving testers early on in the process, we can identify potential issues, maybe with the requirements or the design, before they become, these costly coding nightmares.
That sounds like a very proactive approach to quality assurance. What other principles should we keep in mind?
Well, there's this intriguing concept called defect clustering, which basically means that bugs, well, they tend to hang out together. Think of it like this. If you find one cockroach in your kitchen, chances are there are more lurking nearby.
So if you find a bug in one area of the software, it's worth taking a closer look at that area because there might be more bugs hiding there.
Exactly. Defect clustering helps testers focus their efforts on those high-risk areas, right? Making the testing process more efficient and effective.
Makes sense, yeah.
And finally, we have the pesticide paradox, which, well, the name sounds a bit ominous, but it's an important concept to understand.
Okay.
The pesticide paradox refers to this phenomenon where the same tests repeated over and over, well, they become less effective at finding new bugs. It's like using the same pesticide on a crop eventually. The pests become resistant to it.
So how do testers avoid falling into this trap? How do they keep their tests fresh and effective?
It's all about constantly reviewing, updating, and diversifying those test cases. We need to be creative, adaptable, always looking for new ways to challenge the software and uncover those hidden vulnerabilities.
So testing is not this static one-and-done process. It's dynamic, evolving. It requires constant vigilance and adaptation.
You're absolutely right. Now that we've explored some of those guiding principles, let's dive into the different levels of testing. These represent the various stages at which testing is performed during that SDLC.
Okay, levels of testing, you're making this sound like a video game. Tell me more about these different levels.
Well, think of it as a pyramid, with each level building upon the one below it. At the base of this pyramid is component testing, also known as unit testing.
Unit testing, that sounds pretty granular. What does it actually involve?
Unit testing is all about testing those individual components or modules of the software, in isolation. It's like testing the individual bricks before you build a wall. We want to make sure each piece works perfectly on its own before we start putting them all together.
So it's about ensuring each building block of the software is solid and functional. Who typically performs those unit tests?
Unit testing is usually done by the developers themselves as they write the code, because they have the deepest understanding of how each component is supposed to work. So they're best equipped to create these, granular tests.
That makes sense, yeah. So unit testing is like a developer's self-check. Catch those errors early on before they spread to other parts of the software.
Exactly. And once we're confident that the individual components are functioning correctly, we move on to the next level, integration testing.
Okay, so now we're starting to put those bricks together, building that wall piece by piece. What are we looking for in integration testing?
Integration testing is all about ensuring that those individual components, well, they work together seamlessly, right?
Okay.
We're testing the interfaces, the data flows, the interactions between those different modules. We want to make sure the pieces fit together smoothly and that data is being passed correctly from one component to another.
It's like making sure the plumbing and electrical systems in that house are all connected properly and working in harmony.
That's a great analogy. Integration testing can be quite complex,
Uh-huh.
because it involves those multiple components working together. But it's a crucial step in ensuring that the software, it functions as a cohesive whole.
And once we're confident that the components are playing nicely together, we move up to system testing, right?
Exactly. System testing is where we evaluate the entire system as a whole. Just like you would inspect a finished house to make sure everything is in working order, We're looking at both functional and non-functional requirements,
Hmm.
testing the overall performance, the security, the usability, the reliability of the software.
So it's the grand finale of testing where we make sure the entire orchestra is playing in tune.
You got it. System testing is a critical step in ensuring that the software meets all of those specified requirements and that it's ready for real-world use.
And if the software passes this final test, we're ready to release it to the world.
Not so fast. There's one more level of testing that often gets overlooked, but it's incredibly important: acceptance testing.
Acceptance testing, I haven't heard of that one. What's it all about?
Acceptance testing is all about getting the final seal of approval from the people who matter most, the users. It's about validating whether the software actually meets their needs, their expectations, and their business requirements.
So it's like the homeowner doing a final walkthrough before they move in, right?
That's a great way to put it. Acceptance testing, it can take various forms. There's alpha testing, where internal users within the development team put the software through its paces. Then there's beta testing, where we release the software to a limited group of external users to get their feedback.
So beta testing is like a sneak peek. Give users a chance to try it out and provide valuable feedback before that official launch.
Exactly. And then there's user acceptance testing, or UAT. That's a more formal process,
Hmm.
where the client or the end users, they validate the software against their specific business requirements.
So it sounds like acceptance testing is really a crucial step in ensuring that the software is truly fit for its intended purpose,
It is.
that it meets the needs of the people who will be using it day in and day out.
Absolutely. It's the ultimate test of whether the software delivers on its promises.
This journey through the levels of testing has been really illuminating. It's like building a house layer by layer, making sure each piece is solid, the structure sound, before moving on to the next level. But you mentioned different types of testing as well. What are those all about?
The types of testing, well, they refer to those different aspects of the software that we evaluate. The two main categories are functional testing and non-functional testing.
Okay.
Functional testing, it focuses on what the software does,
Mm.
its features, functionalities, how it behaves in those different scenarios. Non-functional testing, on the other hand, it focuses on how the software performs, its speed, its security, its usability, its reliability.
So functional testing is making sure the car drives, and non-functional testing is making sure it drives smoothly, safely, efficiently.
That's a perfect analogy. Within these two broad categories, there's a whole spectrum of specialized types of testing.
Wow, this testing world is quite vast and complex. Can you give me some examples of those specialized types of testing?
Sure. Let's start with functional testing. One common type is black box testing. This is where testers evaluate the software without any knowledge of the internal code structure. Essentially, they're interacting with the software as a user would, testing those functionalities and user interfaces.
So it's like judging a book by its cover,
Exactly.
focusing on how the software looks and feels from the outside.
Black box testing is crucial for making sure the software is user-friendly and intuitive. Then there's white box testing, where testers have full access to the code and can analyze the internal logic and structure of the software.
So white box testing is like peeking under the hood, understanding how the engine works.
You got it. White box testing is often done by developers during unit testing,
Yeah.
make sure those individual components are functioning correctly. And then there's gray box testing, which sits somewhere in between black box and white box testing.
And gray box, a blend of the two.
Precisely. In gray box testing, testers have some knowledge of the internal code structure, but not as much as in white box testing. This allows them to design more targeted and effective tests.
Okay, it sounds like each type of testing offers a different perspective on the software, helping to uncover different types of bugs and vulnerabilities. What about non-functional testing? What are some examples of that?
Non-functional testing is all about ensuring that the software meets those quality attributes that are, well, they're crucial for a good user experience.
Okay.
One example is performance testing. This is where we put the software through its paces,
Yeah.
to see how it handles stress, load, and volume. We want to make sure the software can handle peak traffic, large data sets, heavy usage without crashing or slowing down.
So it's like stress testing a bridge,
Exactly.
making sure it can withstand heavy traffic and strong winds.
Performance testing is essential for ensuring that the software is scalable and reliable, especially for those applications that are used by like a large number of users. Then there's security testing, which is all about identifying and mitigating those vulnerabilities that could expose the software to cyber threats.
Security is a huge concern these days with all the data breaches and hacking attempts. What does security testing actually involve?
Security testing encompasses a wide range of techniques. You've got penetration testing, where ethical hackers try to, break into the system. You've got code analysis, where we scrutinize the code for potential vulnerabilities. And we also conduct vulnerability scans using automated tools to identify, those known weaknesses in the software.
So it's a multi-layered approach to security, using both manual and automated techniques to uncover and address those potential weaknesses.
Exactly. And then there's usability testing, which is all about making sure the software is easy to use, intuitive, and enjoyable for the end users.
Usability is so important. A software application can have all the bells and whistles in the world, but if it's difficult to use, people just aren't going to use it.
You're absolutely right. In usability testing, we observe users as they interact with the software. We gather their feedback, identify areas of confusion, and make recommendations for improvements.
So it's about putting the software in the hands of real users, seeing how they actually use it,
Exactly.
gathering those valuable insights to improve the user experience.
Precisely. And these are just a few examples of the many types of testing that fall under the umbrella of non-functional testing. There's also compatibility testing, making sure the software works seamlessly across different devices, operating systems, and browsers. And there's accessibility testing, where we make sure the software is usable by people with disabilities.
So it sounds like testing is not just about finding bugs. It's about ensuring that the software meets this wide range of quality standards and user expectations.
You've hit the nail on the head. Testing is about making sure the software is not just functional, but also reliable, secure, usable, and accessible to everyone.
This deep dive into the world of testing has been truly eye-opening. I'm starting to appreciate the complexity and importance of this crucial phase of software development.
It's definitely a vast and fascinating field, and we've only scratched the surface. But, beyond the world of testing, there are other essential aspects of software development that are worth exploring.
Before the break, we talked about the different stages of the SDLC, that crucial role of testing. Now I'm curious about the environments where this software comes to life. Our sources highlight the concept of deployment environments. Can you tell me more about those?
Deployment environments, they're essentially different stages or setups where the software is deployed and tested throughout its life cycle. It's like the software, it goes on a journey, evolving and maturing as it moves through these different environments.
So we've explored the stages of that SDLC. We dove deep into the world of testing and even toured those environments where the software comes to life.
Yeah, it's been quite a journey.
It has. Now I'm ready for the grand finale of our software development journey. What else do we need to know to truly understand this complex and fascinating world?
Well, we've talked about the how of software development, but I think before we wrap up, it's crucial to talk about the what,
Okay.
and specifically the what that drives the entire process.
Requirements.
Requirements, those sound like the foundation of any project,
Yeah.
but why are they so crucial in software development?
Imagine trying to build a house without blueprints.
Total chaos.
Exactly. Chaos. Requirements are the blueprints for software. They define what the software needs to do, how it should behave, and ultimately what problems it's going to solve for the users. Without clear, well-defined requirements, you're essentially building blind.
And the results could be disastrous.
You got it.
So requirements are like the compass guiding the entire development journey.
Yeah. Making sure that everyone's heading in the right direction,
Exactly.
that we're building the right thing.
They act as a contract,
Okay.
between the developers and the stakeholders, ensuring everyone's on the same page, working towards a shared vision.
Mm-hmm.
And gathering those requirements, it's a meticulous process.
Yeah, for sure.
Involves a lot of listening, understanding, and even a bit of detective work.
That sounds intriguing. So how do you go about uncovering those crucial requirements? Is it just a matter of asking the client what they want?
It's definitely more nuanced than that. One of the most valuable techniques is conducting interviews with stakeholders,
Yeah.
the people who will actually be using the software. We ask them about their needs, their pain points, their expectations. It's about understanding how they work, what challenges they face, and how the software can make their lives easier.
So going beyond the surface, really digging deep to understand the user's world,
Yes.
uncovering those hidden needs that they might not even be aware of themselves.
Exactly. And sometimes observing users as they interact with existing systems or competitor products, it can be incredibly insightful. It's like watching a master chef at work, learning their techniques and secrets.
So it's about combining that direct feedback with those real-world observations. To paint a complete picture of what the software needs to be.
Precisely. And don't forget the expertise of the development team itself, right?
Right.
If they've worked on similar projects before, they can leverage that knowledge to anticipate needs, identify potential challenges, and propose innovative solutions.
So it's a collaborative process. You're drawing on the knowledge and experience of all stakeholders
Exactly.
to create that shared understanding of what the software needs to achieve. But once you've gathered all this information, how do you actually document those requirements in a way that's clear, concise, and actionable?
That's where the art of documentation comes in. A well-written requirements document is like a treasure map, guiding the development team towards the goal. It outlines the project's objectives, the target audience, the key functionalities, any technical constraints, and even potential risks.
So it's not just a laundry list of features, it's a strategic document
Yeah,
that sets the stage for the entire development process.
you got it. And there are some key attributes that every good requirements document should have. It needs to be correct, accurately reflecting the client's needs. It needs to be complete, leaving no room for ambiguity or misinterpretation. And perhaps most importantly, it needs to be testable.
Testable. Why is that so important?
If a requirement can't be tested, how can you prove that the software actually meets it?
Right.
Testability ensures that we can verify whether the software is functioning as intended
Yeah.
and that it's delivering that desired value to the users.
Makes a lot of sense, yeah. It's like including instructions on how to inspect that finished house,
Yeah.
making sure it meets the specifications outlined in the blueprints.
Exactly. Well-defined requirements, they are the foundation upon which successful software is built. They provide clarity, direction, and that shared understanding among everyone involved.
Now let's talk about those different methodologies for guiding this software development journey. We've already touched on some popular models like waterfall and agile, but our sources delve into other approaches. What's the V-shaped model all about?
The V-shaped model, it's an extension of the waterfall model, but it emphasizes verification and validation at every stage of the development process. It's visualized as a V because each stage on the downward slope has a corresponding testing stage on the upward slope.
So it's like the waterfall model, but with a built-in emphasis on testing.
Exactly. It ensures that each phase is thoroughly tested before moving on to the next one, reducing the risk of those pesky bugs sneaking through.
Makes sense. And how does the iterative model compare to agile? Are they similar?
The iterative model, like Agile, it breaks the development process into cycles or iterations. But unlike Agile, which focuses on delivering working software in each sprint, the iterative model, it emphasizes continuous refinement. Each iteration builds upon the previous one, incorporating feedback and evolving the product gradually.
So it's less about delivering those finished features and more about constant improvement and adaptation based on feedback.
It's like sculpting a masterpiece.
Yeah.
Gradually shaping and refining it until it reaches that final form.
And what about the chaotic model? The name itself sounds, well, a bit chaotic.
The chaotic model, sometimes called the ad hoc model, is a less structured approach for sure. It thrives in situations where requirements are unclear, maybe constantly changing, and where flexibility is paramount.
So it's more about adapting on the fly and responding to those immediate needs rather than following, a rigid plan.
Exactly. It's like navigating a maze without a map. You're relying on intuition and quick thinking to find your way. It can be risky, but it can also be incredibly effective in rapidly evolving environments.
So it sounds like choosing the right methodology is a bit like choosing the right vehicle for a journey. It depends on the terrain, the destination, and the desired speed.
That's a great analogy. There's no one-size-fits-all solution in software development. It's about understanding the strengths and weaknesses of each approach and choosing the one that best aligns with the project's goals and constraints.
Now let's shift our focus to a specific type of software that's become so ubiquitous in our digital lives: mobile apps. We've already touched on some testing considerations, but our sources delve deeper into the different types of mobile apps. What are native apps and what makes them unique?
Native apps, they're like those who were born and raised in a particular country.
Okay.
They're designed specifically for a particular mobile operating system,
Okay.
Android or iOS. And they're built using the platform's native programming languages and tools. This gives them deep integration with the device's hardware and features, allowing them to fully leverage the capabilities of the platform.
So they're like citizens of that mobile platform they're built for. They speak the native language, enjoy all the rights and privileges that come with it.
Exactly. Native apps are known for their performance, their responsiveness, and their ability to seamlessly integrate with the device's features, like the camera, GPS, and sensors.
And what about web apps? How do they differ from native apps?
Web apps are like visitors from another country. They're essentially websites that are designed to be responsive and accessible on those mobile devices. They run within a web browser, so they can work across different platforms without needing to be rewritten for each one.
So they're more adaptable and portable, but they might not feel as at home on a specific platform as a native app.
That's right. Web apps are typically easier and faster to develop, as they don't require those separate code bases for different platforms. But they might not have the same level of performance or access to all of the device's features as those native apps.
And what about hybrid apps? Are they a blend of both worlds?
Exactly. Hybrid apps are like those who have immigrated to a new country and adopted some of the local customs while still retaining their cultural heritage. They're built using web technologies, but they're wrapped within a native container, allowing them to be distributed through app stores and access some native device features.
So they offer a compromise, combining the cross-platform compatibility of web apps with some of the performance and feature access of native apps.
You got it. The choice between native, web, and hybrid apps really depends on a variety of factors: the target audience, the desired functionality, the budget, and the timeline.
It sounds like mobile app development is a whole world unto itself, with its own set of challenges and opportunities.
Absolutely. And as mobile devices continue to evolve and become even more integrated into our lives, the world of mobile app development will continue to grow and innovate.
This has been an incredible journey through the world of software development. We've explored the structured process of the SDLC, delved into that crucial role of testing, and toured the environments where software comes to life.
We've also explored those different methodologies that guide the development process, the importance of well-defined requirements, and that fascinating world of mobile app development.
We've covered a lot of ground, but I have a feeling this is just the beginning of our software development adventure.
You're absolutely right. The world of software development is vast, it's ever-evolving, and it's full of exciting possibilities. And who knows what amazing innovations lie just around the corner? Perhaps you'll be the one to create them.
That's an inspiring thought. Thank you for guiding us through this fascinating world.
It's been my pleasure. Remember, this deep dive has only scratched the surface. There's a universe of knowledge waiting to be explored. So keep learning, keep experimenting, and keep building amazing things.
To our listener, we hope this deep dive has sparked your curiosity and equipped you with a solid foundation in the world of software development. We've provided links in the show notes for further exploration, so go forth and dive deeper into the areas that ignite your passion. Happy coding!